Welcome everybody. My name is Jake O'Regan. I am a specialist Golang recruitment consultant for companies in Germany. I work at Amicus Recruitment. As a company, we also don't just cover Germany, we also cover London as well for Golang opportunities. So warm welcome to everybody for the latest episode of Golang Live, which is part of our live series event over at Amicus Recruitment. Tonight, the webinar is entitled Microservices, the End of Software Design. I'm delighted to be joined by Ole, who will be leading tonight's webinar. He's the expert that'll be leading it for us tonight. So if you do have any questions throughout, we decided it'd be best if we can do this as we go along. So if you see something and you have a question, please reach out to me. I will then ask the question to Ole as we go along, rather than spending time at the end answering questions, but there will be opportunities to do also. So the session, as I mentioned to people that are just joining on, will be recorded, so there will be access to a link as of tomorrow as well. And it should last between sort of 30 and 45 minutes. So yeah, without further ado, over to you, Ole.
Okay, thanks a lot. Hi, I'm Ole, and this will be my talk, Microservices, the End of Software Design. So a little bit about me. I've got like 25 years of professional software development background, and most of it in Java. And now since like 5 years, I switched to Go. And yeah, for 3 years, I'm now co-organizing the Berlin meetup, our Go user group here, and often worked as a software architect or similar. So sometimes it was called a technical project lead, or nowadays you would call it probably a lead developer. And yeah, that's what I'm currently looking for too. And yeah, let's take a look at how things have developed. What is system software design at all? And we have to go back to the old days of the monolith for that. So back then we had only one system, one deployable unit, right? And no matter how big the system was, and you can see it's a quite big old gopher here, right? And yeah, operations really insisted on this, right? Because deployments were manually, and it was often a very tedious process and so on, with many steps, and nobody would even think about doing this a second time for the same overall system. So it had never been questioned, even by developers, it has never been questioned. And for developers, it was quite easy to add something because you didn't need any scaffolding code anymore. So it was all there. You just found a new package and plugged it in somewhere, and bam, you got it running somehow. Yeah, of course, these systems grew without bounds, and this was quite ugly, usually becoming a big ball of mud. And yeah, this is the thing we want to prevent nowadays. But let's take a look first what it really looks like, this big ball of mud. So this is kind of a typical class diagram back from the old times. See some nicer parts in the outer edges that are digestible, and even in here there's quite a lot going on, but it's quite a simple structure. It should be quite okay. But then in the hardcore middle, this is a complete mess, and probably there will be only 1 or 2 old-time developers who still understand it, and that's it, right? And yeah, it's just a fault because it's just too easy to reuse something, right? You remember, oh, something like this has been done already somewhere, and then you go there and you think it's good because don't repeat yourself and try up the code. This is great, but in the end it looks like this, or even like this in the next example, right? I mean, this is literally a big ball of mud, right? And without the colors, you wouldn't see any structure at all inside it, even though at the edges you can still find something that is understandable, but it's way too big to be useful, and all the middle part, which is almost everything, is just not digestible, right? And yeah, so let's take a look what is software design, because this is really the art that tries to keep this mess at bay, right? It hasn't been always successful, but the definition from Wikipedia is it's like all activities involved in conceptualizing, framing, implementing, commissioning, and ultimately modifying complex systems. I think this is a bit too broad, personally, because there's software architecture too, and the differentiation that I know is that software design is about everything within one single system, so within one single executable and one service. And software architecture is really about more the interaction between this system and the outer world, like databases, messaging systems, other services, of course, and so on. So this is the definition that I will use during the talk too. But you see, it has been a big thing, right? If you look for it, you will find some things. And there has been a lot of books about software design too, right? It has been a really reputable discipline. And this one in particular, I've read and loved myself a lot before switching to Java. And yeah, there's been a lot of other books, of course. And let's take a look at Java, especially since this is the programming language that has been used for like 90% of all the monoliths out there that might be now migrating to Go or something. And yeah, so Java especially allows circular dependencies between classes, which is not too uncommon. There are patterns where you need this, and even in the Go world, we do this too sometimes, but it's quite rare there. And in Go, it's only allowed within one package. Right? This is a huge difference. And here it can be across anything in Java, right? And yeah. But Java also allows circular dependencies between packages. And this is really bad, right? This can be in the big picture that you can't see much because it's all a mess. And this is something that really haunts you, and Go is much better there. We will take further look at that. And yeah, finally, Java doesn't encourage dependencies between projects, but doesn't 100% prevent it either. But I've never heard of any problems because of that. But I think the really big problem is the dependencies between packages. And yeah, this is, for me, Java is broken there, and that's why I have this broken cup here. I wanted to use the official Java logo, but unfortunately I read the Oracle claims, copyright claims, and they say I'm allowed to use it, but only for Java, the language, which I would do, and only if I use it in a positive way. And I wasn't able to do that, sorry, right? So I thought this image would be at least as appropriate as the original logo. So I'm happy to do that. And so let's see what tools we have as, for software design. And the old school IDEs contain quite a lot of tools for analyzing and for refactoring, really. And you have things for structural analysis, like how a class itself is structured and how it interacts with other classes. And you can do renaming classes, methods, variables. those things we have quite a lot in Go too, I think. This is already quite good. In Java world and these big IDEs, you can move classes to other packages, and you can move methods to other packages or other classes too. And this can be really nice sometimes. And something like that I would love to have in the Go world. If you know of something, please tell me, right? And finally, you can extract methods easily, that you split one method up and mark just some lines of code and say extract as an own method or own function, and you got a new one, including all the parameters that are necessary and so on. This is really nice. If you find this for Go, please tell me too.
We've just Dino's just commented in and said that, hi Dino, by the way. Golang works well as an IDE with those functionalities.
Yeah, they have it. Okay, I didn't know that. Now there are no official command line tools, but Golang has it all. Okay, then
yeah,
it's
a paid one. Apparently, it's a paid one.
Yeah, I know. But that would be reason to switch to it.
Yeah.
That's great. Yeah, then
Thanks,
they
guys,
moved it all from the Java world over to Go to. That's great to know. So yeah, I have a reason now to recommend Golang. Yeah.
Good.
Thanks. One of the main developers is a really nice guy, has been in Berlin too for many years, and former organizer of the meetup too. So I know him a bit. Yeah. So all nice. And yeah, big companies, of course, they have often their own specialized tools. Especially Google is very famous for it. I haven't worked for Google, so I don't know everything about it, but everything I heard must be a real wonderland for developers, and must be really, really great. Yeah. That's all nice. But now we are in a new world, you know, we have microservices. These are very young, like babies, but we have many of them, right? And so it's more like one system and 1,000 deployable units. And it's really that the DevOps culture and everything moving to cloud and so on, this insists on this kind of, it's just you have to do this. It's rarely questioned. I haven't seen a lot of discussions about it, and yeah, I would like to see it a bit more. Sometimes I think it's not a perfect way, and if you do cloud infrastructure yourself or something, it's of course great that it comes from, but there are other use cases for business software. It's not always perfect. And yeah, I would like to have it a bit more discussed. Systems grow without bounds still, right? This is just what they tend to do. If something works and you have a great new idea, you just add it somehow. And now you don't have a big ball of mud, but you get some spaghetti architecture instead. And yeah, so the Go code looks still nice and clean because all the services are nice and clean, but now you have kind of a spaghetti YAML instead, right? And did you know YAML isn't even a typed programming language? In fact, it's not a real programming language at all. It's just a configuration language, and refactoring there is much harder, of course. And so let's see what it looks like in practice. This is from Uber. You might recognize this image. Yeah, you know, it is really the service diagram from Uber, and it comes from this nice blog post where they introduced the domain-oriented microservice architecture. You know, real class diagrams are impossible to be found on the internet nowadays because they are hidden and nobody wants to show them, and you can't see much on it anymore anyway. And the main difference is that there were different kinds of arrows with different meanings. If you had would extend a class, inherit from it, or if you want just use it or something else. So we don't have this nowadays so much in these service graphs, but they are still quite a mess, right? And yeah, it's hard to come by. And nowadays, it's not so easy to reuse some part of code in another service because it's far away in a different service. But nowadays, you can just listen to another topic easily, right? You have these nice messaging systems and they decouple a lot, but you just listen to another topic and bam, you get the information that you're looking for and can work with it. That is the new way to create this chaos, right? Each topic that you add draws another line and bam, you got a lot of dependencies. And yeah, this one is from Monzo, their famous blog post. How do they keep 1,600 microservices spinning? Yeah, go clean code and a strong team. Yeah, it's almost a wonder, and it's would suggest that it's a very strong team. And if a lot of the old people who have built this up and all the important parts in their head would go, then they would have a really hard time, especially if it's not so fancy anymore to use so many microservices. Then they would have a hard time to find good developers who are still able to work with such a thing. But let's see, I wish them luck, and they might have good enough tooling until then. They are a big enough company. So let's hope the best. Let's take a look at the downside.
I've just had a question through. It's more of a generic question, but which is the best linter for Go? Something embedded in VS Code. Any ideas on this?
Oh, I'm not a specialist on this. I personally just using Vim, and there's a Go plugin for it, and there are some linters suggested, and there's a meta linter that includes like 5 other linters automatically, and that's what I'm using, and that's working for me. Right? That these linters, you have to know, they don't find the big problems. They show you the tiny little problems. It's good to take care of them quickly, but they won't prevent the really big problems, and I don't invest too much time.
No worries. So we've had 2 or 3 suggestions. So thank you everybody who's joined in on the chat column there. I really appreciate it on that one.
So I take whatever the company policy is, and it's usually quite okay and good. And I'm happy with that. And I concentrate my energy on the big problems that really hurt the whole day.
No problem. Cheers.
So yeah, let's think about this, right? We had this 1,600 microservices, and now we want to update one dependency. Just want something very simple like a logging library or so. This can be really hard. If you don't have this perfectly automated, this is absolutely awful. And if there's only a tiny little change in the API, this can be extremely hard to have. Like 95% you can do automatically, but the last 5% can hurt so much, and you have to do so many additional manual interventions, and the tooling has to support it and so on. This is really hard to do. So this is no fun, unfortunately. I've done this myself with a bit smaller number, but still it was awful enough. And moving functionality to other services. This is even more tedious. You don't have to do this on the same scale usually, but I've never seen something much better than copy-paste. And most people just say, oh, you don't have to move it because it's already more or less perfect the way it is. And yeah, but in reality, it rarely is, and things change, right? And so this can be really bad for you, especially if you would love to cut services in a different way, right? If you did one of the big no-nos of distributed services like cutting your big monolith into tiny entity-based services, that would be really bad, right? Then you have distributed monolith, and this is really, really bad. And getting away from that is so much harder than fighting a real monolith. So yeah, I hope you have done a bit better. And there are other patterns that can be quite bad too. I've worked with a really modern and fancy CQoS architecture, and it's okay, but it is way more complex than necessary. And if you want to ever go away from that, it's very hard, a lot of work. So almost impossible. It's almost rewriting everything, since most of these tiny services just contain a few lines of business functionality that you have to extract, and it's often scattered between switch case blocks where you handle messages and so on. And so this can be really awful, unfortunately. But let's see. Yeah, we have the upsides that Go provides to us already out of the box, because Go has been engineered from ground up with scalability in mind. And this is really nice, and it shows in daily life quite a lot, I think. Packages are made for encapsulating functionality, of course. And it's the only thing that we really have for encapsulating, but it works really well. And dependency cycles between packages aren't possible. And this is a big one. This is something that is really, really great. And I'm absolutely happy about that. So you can't have complete chaos, because it always has to be a somewhat hierarchical structure, right? And finally, tooling for preventing other unwanted dependencies between packages is really simple, right? You can do this with command line tools, as is often done in the Go world, and this is quite simple to use. And I would like to show an example for that, the spaghetti cutter, to win the fight against spaghetti cut, right? And yeah, I made that up myself. So here it's open source. Here's the URL, and please, you can use it. It's documented, and yeah, it's a command line tool, really. It's simple. You can use it in the continuous integration pipelines, and of course on development machines too. And it prevents Go spaghetti code really with error messages in the return code. So if it returns a non-zero return code, the CI pipeline can fail, and then the alarm button is pressed, and yeah, then you know you got to do something. So it prevents Go code. It's not magically cutting anything. Sorry for that, but spaghetti preventer wouldn't be a nice name, and spaghetti cutter, and you get a nice image for it. And so yeah, I went for that instead, right? But the end result is the same. You don't have spaghetti code, right? This is the important thing, and that's what we want to have, really. And finally, the configuration for this tool gives a really good overview of the project. It's really great documentation, especially for new developers who just join the project. They have one screen full of configuration file and a complete overview of how the project is structured. And I think this is even the biggest benefit. And it is verified by the CI pipeline, and so you know it's true. It's something you can depend on, and you know it never lies. And this is something that I would recommend a lot. So if you call it, it only has one option. So the default root directory for the project would look in the current directory. Otherwise, you can give it another directory as the option. But it really crawls up from there the directory path to find its configuration file. And the configuration file, as I already told you, is a central part of it. And yeah, central part of this configuration file is, of course, how you can configure packages or paths for packages. And so it can be a simple path, of course, but they can be nested too, for sure. And this is now the interesting part. You can have stars. So you can say everything that starts with X slash. So right, we know this, or typically, or everything that ends with a DB package, right, and so on. There can be other special cases. You can have multiple stars. Here you can really declare what your structure is with those stars. You can easily communicate. Are the conventions that we have for structuring projects here. And only a couple of lines, and then it's completely clear. Yeah, okay, you always have these sub packages and normal domain packages, or you have a database package like this and that, and so on. So this is something that you should please use quite a lot. And another nice trick is if you have a domain package or any package really, and you want to include the additional test package that you need or is generated for API tests, which are really nice in the Go world, then you can just add a star to the end and the underscore test will be included too. And this is something that I'm using sometimes. And finally, there is a double star possible. This matches anything, including slash. And so I only allow it currently at the end because anything after it is matched by it. Would be possible to allow it in the middle, and then it would still match anything, including a slash, but it wouldn't allow something without the last bits after it. But yeah, I'm on the fence with that. If you would like that functionality, I would be happy to add it. Please tell me or open a bug or something, feature request. I would do that. I haven't seen any use case for it at all yet, but if you have one, please approach me. So let's see how we can use these. And there are different kind of packages. So first of all, we have these tool packages, right, who usually live under X. And yeah, these tool packages, they can be used anywhere within the project, but they aren't allowed to use any other packages themselves. Right? Tool packages stand for themselves. They are allowed to use external dependencies. Often they wrap an external dependency to give a nice API. But this is all, and they aren't allowed to use other tool packages themselves. And then we have database packages. These can live wherever you want, and here you can use these with the stars a lot. They can use the tool packages. They are allowed to be used in the normal business packages, but they aren't allowed to use anything next to other database packages or tool packages. And of course, there are the normal packages for business functionality. This is everything that is not named explicitly here. So I hope it's quite a lot, but often nowadays it's not that much, but this is your choice, of course. And finally, we have special God packages. And a God package is a package that can see everything and use everything. And you should be very careful with that, of course. And the usual standard in Go is to only have main packages being like this. Right? Main package is where you couple everything together. And so this is the default here too. If you don't name any God package, you will have main as the God package. And if you don't want even that, you can restrict it even further with this no God flag, right? Then you don't have any God packages. If you give an explicit God package, then main wouldn't be a God package either, except if you add main here, literally again. So, and finally, there is one loophole you might recognize. If you force some structure, there are some lazy but very clever people who don't want to split up things too much, and so they cram everything into one huge package. And so you can prevent that by giving a maximum size. Yeah. Right, the size, there's no official metric for this, and so I chose some version of complexity. It's kind of minimal lines of code. So if you split your code as much as possible, then you roundabout get the number that you get here. And it's a quite fair measure because comments and documentations aren't counted, so nobody will delete that just to get a nicer number here. And imports aren't counted either, so you can split things up into multiple files and so on. All these things are good, and long identifiers don't count more than small identifiers. So being explicit on any level is good, and you won't get penalized for anything like that, right? Good behavior should be encouraged and not penalized, of course.
Ole, I just had one question come through from Narendra. So Narendra just asked, why do we not use a main package?
Why don't you use, you use a main package usually. You need a main package if you want to have a main that starts the service or something, of course. But you don't want everything crammed into only a main package. Right? Main package is usually the God package that can see everything and just plugs it together. Right? Main package, idiomatic Go code has the role to work with command line options and arguments and to take care of environment and then plug everything together. And that's all it does. And it's usually not big, right? You sometimes have routes.go in there for web services. So there you have all the routes in one file declared. This can be really nice. There you can see all the entry points and start searching from there. But it's not a huge package, right? Everything else should be living outside of it. And then you can split it up nicely and can get it under control and have a nice structure, and things are much easier for new people to understand due to that.
Perfect. Okay, thank you very much.
So let's see, next to the general configuration. This is often not enough, right? This is the ideal world, but often you need some additional things. So this allow additionally key makes this possible. So you can read it as allow superdomain to also import or additionally import subdomain 1 from domain X and subdomain 2 from domain Y. And this can be really useful. So you just name the package that should be allowed to import more first, and then a list of all the things that it needs additionally. And it's not that bad since it's explicit here, right? And you should add some documentation why this is necessary, or what is the pattern you are doing there. And then it's okay. You can understand this, and it's relatively easy to work with this. Of course, you shouldn't have hundreds of lines of this, but we have all the nice stars for this, right? So you should have some patterns and good conventions, and then it's not so difficult. And as an example here, it's not a nice one, but still shows what's possible. Even a tool package can be allowed to access other tools in database packages or domain packages or whatever. So this can really override all the restrictions that you have put in place before, but it's explicit. You really say, okay, this is allowed, and it's good to discuss this in the team before doing this, but then it's fine, and then everybody knows about it, and that's okay. So last but not least, there's another little thing that you can do. You can restrict some things.
Sorry to interrupt, Ole. I've just had one question come through. This is from Dino. So does Spaghetti Cutter disallow all package dependencies by default if they are not configured?
Yes, kind of, exactly. What is not, I mean, the defaults that the database packages are allowed to use tool packages, and all unnamed packages are domain packages who are allowed to use database packages and tool packages. So this is the default, and everything that is not according to this default has to be explicitly allowed.
Thank you.
Right? So I tried hard to make the typical conventions from the Go world explicit there and the default, and so you don't need many lines of configuration for a kind of standard Go project, right? And everything that is more special, that has to be explicitly declared. So you only see the special cases and can get a quick overview, right? This is, as I said, one of the main goals of this.
Dino says thanks.
Yeah. So, and finally, there's allow only in, right? You can use that to restrict things. So you can say, allow this package only in the other packages that are the values. So I use this mainly for external dependencies, especially, for example, you want to say that the Postgres driver should only be used in the database packages, which makes a lot of sense, of course, right? And so nobody can access the database directly behind your back without even a database package or something. And yeah, let's take a look at the output. So first of all, it informs about its configuration, where you can see any problems or something misread, or if it did read the wrong configuration file or whatever. And this is an example from the tool running over its own source code. So it's using HJSON, as I told you, and it's only allowed to use that in the configuration package, right? Which is the tool package. And this makes a lot of sense, of course. And then there are the Golang X tools, which give me the parser for Go source code. And yeah, Go source code should be handled by the packages dealing with the dependencies, with the size restriction, and general path package that's wrapping everything a bit, and a small helper tool package that makes some things easier there. And that's it, right? And I have no need for additional allowances. God package is only the usual main package, and that's all I need. So I needn't configure it at all. As tool packages, I have everything under X, which is standard in the Go world, and this path package. It's not a tool package, but it doesn't have any dependencies, and so I use this and declare this as a tool too, to make it a bit more explicit. I don't use any database. Size for me, 1024 is enough. So I'm using that. I don't use the no-God flag, so the default here is just fine for me. And this is the root package. It's, as you might remember, the GitHub URL. And yeah, then it reports the sizes of the packages. So you don't have to blindly guess any size configuration, but you can just run it and it reports them. And we can see here that the size package itself is the by far biggest one. And that's why I use the 1024 there. And of course, I have to judge the size of any kind of source code, of Go code. And so I have to be able to read any kind of Go code, and now Go functions can contain Go statements, and those contain Go expressions. And there's one special expression, which is a closure that contains a function again. So we have a loop. And so it has to be all within one package. As we know, we can't have cycles between packages. So this is why I do this all in one package, but it's still not huge, and I'm quite okay with this. And yeah, some additional tools, no errors found. And if there would be errors, they would be reported here instead of the last info. And that would give you the packages that violate the rules and what configuration rule has been violated. So you can easily do something about it and return code that is non-zero, so your CI pipeline can fail. And that's it really, right? Yeah, let's see what we can take away from this. So I think software design currently is really dead in microservice land, because microservices don't contain too much code. It's not that useful in there currently. But you pay quite a high price for it, right? So you have all these difficulties of moving code around and so on, and refactoring that I talked about. And I would really love to have something in the middle, something reasonably sized, not religiously all into one, but not religiously cut as small as possible either. And yeah, just split up where it really makes sense, where things are really independent of each other, or you really want different kinds of scalability and so on. And if you just want to have larger read scalability than write scalability, which is quite common, you don't have to do CQRS. You can simply do the normal layered architecture would be read-write, and then have a second main package, which is a copy of the normal one containing a second routes.go where only the read routes are included, and bam, you have an executable with only reading. And this is quite simple and very maintainable, and way easier than having like 3 times the number of services. And
so just had one quick question,
yeah,
just on that, Ole. So the size parameter, does that look at the number of lines allowed within the functions, as well as the total of lines of code within the package?
It doesn't look at lines at all. So you can structure your code anyway. It doesn't matter at all. It really is parsing the whole code. That's why it's so big. And it's really analyzing only the structure. Whether you have split it up in many lines or all in one line wouldn't really matter. It only penalizes the structure, so the complexity of the Go code itself. And you can nicely format everything and split it up into many files, or have many empty lines or whatever. This doesn't matter. And if you want to restrict the number of lines within functions, there are these typical Go code quality analysis services. And they do this quite nicely and reliably. I would advise you to use that. This tool is more for the structure between packages, because this is something I haven't seen taken care of anywhere. And as packages are the bigger structure, it's overall the bigger problem, right? If you have a big project with lots of packages, yeah, taming one package is relatively easy, but taming all packages is the hard part usually. That's why I want to work on this.
Okay, and I've just, I know it's probably a good time to people to ask questions. I've just had two more come through. Do you consider Spaghetti Cutter stable enough for a production CI pipeline? Question one.
That's what I've been building it for. I'm still testing a few edge cases. So I think next week I will have a new version, and then wait a few weeks and publish version 1.0 that is truly stable for CI pipeline. But it's good enough for starting to use it and testing it, giving me feedback. That's great. And it's it should be good enough. Right, okay. But I doubt there might be one or two edge cases that I didn't handle properly.
Yeah. So. Okay, and then a second question. How would you approach the dependency issue in big microservice systems with necessary library like a logging library?
I didn't get the last part.
Oh, sorry. I'll start the question again. So how would you approach the dependency issue in big microservice systems with necessary library, with a necessary library like a logging library?
Mm-hmm. Yeah, as I said, of course, you want a logging library. This is fine. You can use this restrict for restricting usage of external dependencies too, but this allow only in. But it doesn't make sense for a logging library. Of course, you want a logging library to be used everywhere, really. And so you don't want this restricted in any way. And this makes sense, I think. And you can have an own small facade in front of the library to give a stable interface, and then call the real library within that if you want to, but otherwise it's okay to use a logging library. Just if you have this as a dependency in 1,000 services, it's much harder to update than if it's a dependency only in one service, right? And if you want more stability, then creating such a small facade package is quite good. It can be your own internal library that you use anywhere. And then you can prevent API changes from getting through to all the services. Right? This is something, if you do something really big, the bigger the thing scales, the more you have to do things like that sometimes.
Thank you very much, Ole. Thank you for that.
So, yeah, and finally, tools like this can help preventing spaghetti code. So yeah, I would love to live in a world with something in the middle, and yeah, let's see. So please enjoy your pasta in nice bites. Right? And thanks very much for listening. And now please additional questions if you like.
Yeah. I think everybody might be having spaghetti bolognese for their dinners tonight. No, but thank you very much, Ole, for that, for obviously speaking and taking the time to conduct the webinar this evening for everybody. As you can see there, Ole's details are there as well, and feel free to ask any questions now. I'll give everyone a minute or so to ask any questions that you feel that you have at this stage. But if you don't, then thank you very much for for attending. It's been great to have you all. Please tune in to the next one. I don't think there's any questions coming through, so I think we'll leave it there then. Ole, there's no questions coming through.
Yeah,
we asked obviously quite a lot during the webinar itself, so thank you, Ole. Thank you everybody for attending.
Thanks.
And I'll be sure to send out the link to everybody who was in and out today, going forward for tomorrow. So thanks guys, have a nice evening, and see you later. Thank you.
Yeah.